Hello, my name is Andrew Ho, and I'm a program manager for the Azure Cosmos DB product team. In this session, we'll be covering API for MongoDB, which is a part of Cosmos DB. For those of you who are wondering, what is Azure Cosmos DB? Azure Cosmos DB is the evolution of Azure Document DB. It is still the same globally distributed, low latency, planet-scale database you've come to love, but now it supports multiple models as well as multiple APIs. Cosmos DB still works with your Document DB documents, but now it supports as a graph database, as well as a key value store, and much more. Session objectives and takeaways. What is the API for MongoDB? First, I'll talk a bit about what is the API for MongoDB. I'll provide a description about this offering and the important things to note about it. Next, we'll talk about why do I want to use API for MongoDB. In this, I'll cover a few of the benefits that really make this special. Lastly, I'll dive into a demo about how to migrate a Cosmos DB database with MongoDB API. The what? Azure Cosmos DB has a number of APIs that allow users to interact with the database in their most comfortable API and SDK. As of March 2017, we announced the general availability of the MongoDB Wire protocol, which enables users to leverage their MongoDB knowledge, drivers, and tools. Underneath, the MongoDB Wire protocol is the same Cosmos DB database technology for global scale and low latency requests. It has all the benefits of a mature PaaS offering with the familiarity of the MongoDB Wire protocol. Over the past year, during the product's public preview, the API for MongoDB has experienced tremendous growth in the number of users and usage. It works with your favorite management tools such as Mongo Chef, which is now rebranded to Studio 3T, and RoboMongo, which was recently acquired by 3T. The why. API for MongoDB leverages the same cutting-edge technology of Cosmos DB, which means you still have the native global distribution. You're able to replicate and have a presence in over 30+ Azure data centers across the world. You have the access to automatic multi-region replication with just a click of a button. And you can trigger manual failovers for business continuity and disaster recovery testing purposes. You have automatic failover in case there is a natural disaster that affects one of your data centers. You still inherit the latency, throughput, consistency, and availability guarantees that Cosmos DB provides through strict, financially backed SLAs. Cosmos DB still supports a guaranteed low latency. With low latency, you have the globally distributed reads and writes that can be served from any local region to hit your low latency requirements. The Cosmos DB database engine is write optimized, latch-free, and designed for SSDs. And the Cosmos DB allows you to have the synchronous and automatic indexing and a sustained ingestion rate. All of these are applicable to the API for MongoDB as well. Using the Cosmos DB database technology, you can elastically scale from 100 to tens of millions of requests per second across any number of regions. We support hourly billing, so you can scale up and down to reduce costs during downtimes, such as when business hours are over. We have automatic partition management, so you can scale to any number of partitions horizontally. In this example, one large retail customer of ours had to scale up for Black Friday. They were able to use the hourly billing as well as the elastic scale to scale up for Black Friday and scale down afterwards. As always, we have enterprise-grade SLAs, which are service level agreements. We durably commit your data, so no data loss. Cosmos DB supports majority quorum committed, synchronous, and index writes. Recently, Cosmos DB has redefined the enterprise-grade SLA standards by defining and supporting 99.99% SLAs on availability, throughput, low latency, and consistency. We have a quick demo for you which showcases one of our globally distributed database with a worker roles distributed across different regions in the world to show the low latency as well as the global distribution. In this demo, we have databases that are globally replicated from South Central US to West Europe to Southeast Asia and East Asia. And we have applications that are set up in South Central US, West Europe, South India, which is different from the databases, and Southeast Asia and East Asia. As you can see, we have the single millisecond latencies for all applications that are co-located with the database. You can see with South India, since the closest database is in Southeast Asia, it's traveling and the latency is reflected within the client-side telemetry we're collecting. Finally, the how. I'll walk through a simple migration of a MongoDB application to Cosmos DB's API for MongoDB. I've gotten a simple sample mean app from online on GitHub to showcase how easy this is. I've set it up to actually work against a local instance of MongoDB. So if I start my local instance of MongoDB, I could then start my local mean stack app. And once this is running, I can showcase the application. This is running on localhost 3000. And as you can see, my application is running. I have a couple data points already there. And I can create a new one just to show you this app is actually running against my local MongoDB instance. So I'll name this build 2017. Gender will be what's it to ya. Age, I'll make it 2017. Favorite language will be English. And I'll put myself right in Arizona. As you can see, I've added a new data point. It's reflected over here. And this is running very smoothly. So let's say I want to migrate over to the cloud API for MongoDB. The migration is actually very simple. All I need to do is head into my application's config file, which has the URL set to localhost. I need to go into the Azure portal and retrieve my connection string. Oh, actually, it's even faster to go to Quick Start. Click on the node.js tab, extract the connection string, and paste it into the URL. Yep. And I'll set the port equal to the port set in the connection string, which is 10250. Save my changes, and restart the app. It's already up and running. I can go back into my app, refresh the page, and as you can see, it's connected to my API for MongoDB application, which has no data points, so it's empty. So next step is to migrate over the data from my local instance over to my API for MongoDB. The simplest way of doing this, let me just restart my MongoDB instance. The simplest way of doing this is to do a Mongo dump. Set to the local host with the database test, collection, Scotch users. So this collection, as well as database, is created directly from the application. I click enter, and I did a Mongo dump of my 10 documents into my machine. Now I can do a Mongo restore. I've saved the command already to save us some time. And what this is doing is doing a restore of the Mongo dump into my endpoint for API for MongoDB. It has my username, my password, the database I want to enter it into, the collection name I want to enter it to. I enable SSL for security reasons, and I put the file path to my dump. I enter, and I've imported all the documents into my instance online. Now, if I go back, find over here, if I refresh the page, it should have all the data points that I put into. And now I can also still use the functionality of MongoDB by adding a new data point, Bill 2017 version 2. I will be male this time. Let's put this as 25. French. Submit. And as you can see, a new data point was entered. If I were to go into the console and shut down my local instance, shut off, OK. And this should still be running just to prove that this is hitting against my instance online. And I can always go into the Azure portal and explore the new data. So if I go into the Query Explorer, run a simple document DB query on it, I can see some of the data that's already been installed inside. And that concludes this video session. Thank you for spending the time with me. Here are some resources for you to get started, to connect, as well as to migrate to the API for MongoDB. My contact information is below. I hope you enjoyed this session. Thank you so much.